I'm gonna take you to places you've never been before. Look at that. That is the real belly of the beast. But something is missing. Right here in this slot sits the computer, and in the next slot sits a card that is vital for the CNC to work properly. I took him out because I need to repair something. Welcome back to the shrine. These are the two boards that I removed from the CNC. This is the expansion board that has some of the signal coming in particular the signal from the encoder. I had the motor issue, the spindle issue surfacing again when the spindle is not spinning in a proper direction, and I went down into the rabbit hole and just looked at the traces and connections. So this is the connection where the encoder's Z signal comes in, and I was going in and trying to figure out if I can find something tangible that would lead me to believe that's the problem. So while I was doing that, I went to look at the computer, and here you can see the computer itself. I never seen something like this. Check this out. It's got a nested IC. So there's a little IC and there's a socket around it, and you can pop another IC on top of that. So this one has a lot of dust on it, as you can see from the amount of dust on the memory modules here. But the real problem why I took it apart was this fan. This is the CPU. I assume that's the CPU, so that is what's being cooled here. And it's got the NLM sticker, production support 004MR. So the real problem was this fan. So watch what happens. You see the fan is like real wibbly wobbly, and when it's running you can actually see that doing this. Now the problem is, if this fan stops and it will not provide cooling to the CPU, then that can cause a real big problem for me. So I decided to take it apart, do a little bit of cleaning, and then put it back together. I honestly don't think this will ever work again at this point. I will try to do it, but I also have a plan B of putting Mach 3 on it. So let's see if I can pull this off. So this is the clips that is holding the fan on, and I've seen this design previously. If I can unlock this, then the fan simply should come off. But as you can see, the fan doesn't have a plug-in connector here, but it's actually soldered into the board. So these are the solder joints, which just frightens me. So let's take the memory modules out so that we can get a better access to the fan. This is HYM memory module, compact, made by Compact, but it doesn't show the size, and all it has just 4 chips on it, made in Korea. It has just an immense amount of dust on it. So this fan is holding on tight. It doesn't really want to come off. I'm afraid to pull the fan off with the chip. This is the lever that holds the chip. So once I release that lever, this entire thing will come off. This is a socket 7. Well, I had a couple tense moments, but as you can see, it's got this grid array. I think it's called FPGA. It's a socket 7. The array is a socket 7, so that would date it to Pentium 5, you know, just around the turn of the century. Removing this old heatsink was a pucker, I gotta tell you. I waited 3 or 4 days until I had enough mental strength to get down to the task, and what I ended up doing is I heated it up with a heat gun, which basically softened this adhesive or thermal interface material, and then I used a twisting motion, and that did the trick. So I was able to remove it. As you can see, I cut the cord, and this is the old fan. The fan blade has seen better days. I'd say it has about a 1/4 inch axial play, and it's not long for this word. I'm not even sure what holds it in place. I tried to remove this sticker, but there is no bolt underneath. I think it's glued in, because there's no bolt on the back side either. So I scraped off the TIM, and now I can see the end of the shaft here is revealed, and there is this little clip that if I remove this clip, the fan is supposed to come off. So it's just a little plastic nipshit trap, as you can see. It's just a plastic clip that clips onto the shaft. So once that is removed, the shaft and the fan should come out. And there you have it. There's the fan. As you can see, it's seen better days. So you can see there's a bearing here, and the internal race of the bearing is completely loose. It's kind of wibbly wobbly, and looks like there's a lot of fret wear in this area on the PCB. As the fan was moving and wobbling, it wore the PCB out. So really this fan was not long for this world. That's the first heatsink I've seen that is stacked and riveted. You can see the rivets here. So there is 8 rivets, and it's riveted the stack together. And I was doing a search to buy a new fan. I haven't seen anything like this. I haven't seen anything like this before. Well, anyways, I went ahead and I ordered 2 new fans, and I wasn't sure which one we'll get here first. So this is StarTech.com socket 7. This is a socket 7 processor, and here's the fan assembly. So that's more familiar. You can see it's a higher stack, so it's, I'd say, twice the size. So it's a taller fan, but I got enough room within the computer, within the cabinet, to accommodate this fan. Also, you can see that the fan has most likely a lot more surface area from what I can see, and it's got a nice smooth ball bearing on it. Look at that. When you stop it, the fan is gonna wiggle into position, and that is due to the cogging torque within the motor. So you have permanent magnets on the fan, and so it aligns itself with the stator pole. It's got these 2 different cables. I will probably cut the cable and just solder it in. So here's the other one. This is a CPU cooler for socket 7, application for Intel, AMD, Cyrix, IBM. This probably works on iPhones too. Easy installation, super CFM. auto detection, 2 years guarantee, high quality. It's just funny, Super CFM. The marketing guys just had a field day on this box. Okay, here's the other fan. You can see size-wise it's a little taller. So should I have any issues with the assembly, you know, I can use either one. These are not expensive things. These are $10–15 range, and I just, you know, wanted to have a spare one here. I'm building a cache of spare parts for my CNC. As you can see, the fan is the same size. So I think I'm gonna go with this guy. I use this blow-off duster to clean all the key areas, both on the RAM and on the motherboard. I gotta tell you, having a cootie on this one would come handy, literally, because when you use this for extended amount of time, it will get really cold, and that is due to expanding the gas inside. So gotta get a cootie for this. This is all the old TIM material, the thermal interface material that I removed from the CPU and from the heatsink. I'm not gonna reuse that. I'm just showing you how much there was. So the next thing I'm gonna do is clean the contacts along the RAM, and I'm just gonna use a rubber eraser. This has enough abrasive quality to kind of rejuvenate these contacts. This seems to be an older model RAM. It doesn't have gold-plated contacts, and so if you look at any of the new RAMs, I have two examples here. You can see these look yellowish because they got gold plating on them. This is for a laptop, but you can see the golden tone. And on these you can see the silver tone. So this is not gold plated. So I'm just gonna go and do some cleaning, especially removing large spots like this one here. Look at this side. It's like completely oxidized and dirty. Cleaned all the contacts here, and as you can see, these are gold plated, also gold plated on the bottom side. I cleaned the contacts for the RAM, and the RAMs only go in one way, so these not supposed to go in backwards. So as you can see, it's got a key here. There you go. So they only go in one way. It has a key in the center here, and it's got a key at the edge. So you got to make sure that you load these RAM modules in the proper way. Looks like they both are seated. So an Arduino probably has more RAM these days than these two. I believe these are 4 megabyte modules, so there are 2 of them, so that would make it 8 megabytes. That is mega. 8 megabytes of RAM. That's all it is. I also cleaned the CPU with a blow-off gun. These go in one way only. So if you look here, you see this corner is missing 1 pin. As you can see, the rest of the corners have all the pins. So there's like a triangle here missing, and there's a triangle on this side that is missing. So the CPU goes in one way like that. So this should be open fully. Then you load in the CPU. It should go in flush. Okay, and then while you're holding it, you close the lever and you latch it in, and so that locks the CPU in place, just like that. So the next thing is installing the fan. I'm just gonna go and do a dry test. Now when I put this on, you can see it wobbles a little bit. So what we're gonna do is we're gonna install some of this thermal paste. Okay, it's ZMSTG5 from Zalman. Zalman is a well-known manufacturer of cooling systems for CPUs and GPUs. Super thermal grease. We're gonna put some of this wonderful material right on the top. So we only need in this area here where the actual CPU is. This probably has fairy dust and nanocrystals and some other stuff in it. The thermal conductivity coefficient is in a range of 4. These are expensive materials, and they most of the times contain silver. So when I attach it, as you can see, these clamps are going to provide a constant tension relative to the CPU, and once it heats up, I think some of it might reflow. So there you have it. This clamp is attached and that clamp is attached. You know, I can wiggle it a little bit, but under the constant tension, when it heats up, that material is going to spread out. I mean, it's specifically formulated for this task. So now we have a huge issue here connecting the leads. As you can see, the lead right here doesn't have like a plug-in socket for the fan, so it's just soldered in, and I am just not in a mood to go in here and unsolder it, especially I mean, look at the traces. You know, it is the finest trace that I can imagine working with. So I don't want to go in here with a soldering iron. I can probably pull it off, but there's a chance I'm going to screw something up. So instead, what I'm going to do is just go and splice these wires together. Okay, just cut it right there and just splice them together. I think that's the right thing to do.
Twice. So it looks like the film was just shot twice in 2 different languages.
Come on, Susie. Come on.
It wouldn't look like I was not myself.
Yes, there is a lot of modern technology from being able to have an extra layer of communication that you get from Facebook.
Mike Seymour picks up from the TED stage.
We're interested in a combination of things coming together. This tremendous...
Faces on our technology. Tell me...
People are like, I have trouble with that. It's a lack of authenticity that probably bothered you, not the digital representation.
Just adding a little touch. Make sure that this cable is just not flying there, flopping in a breeze. There you have it. So the fan replacement is completed. I'm gonna go install it and hopefully get back with you in 2 seconds and provide positive message. As you can see, the surgery was successful. The motherboard is back in its place. The computer is running, the fan is running. Everything seems to be working properly. Thanks for joining in for this repair. Hope to see you on the next one. Bye.